In today's lesson, we're going to look at the properties of a new quadrilateral, the parallelogram. So you'll see we have a parallelogram, MATH. I've already graphed mine on the coordinate plane next to this. So if you want to take a second and pause the video and just make sure you have the same picture. Then just like we did yesterday in class, we're going to calculate the slope of each of the four sides. So you should notice that MH has a zero slope. It's a horizontal line, just like AT. And when we look over at HT, it's going down 1, 2, 3, 4, and over 2, which we know can simplify to -2. And for MA, we're going down 4 over 2 again, which is also equal to -2. So a little different from the trapezoid we saw yesterday. If we see these slopes, we know that both pairs of opposite sides are parallel. Anything to do with parallel either tells us, everything that does with the slope is either parallel or perpendicular. Because MH and AT are the same, they're parallel, and the opposite sides, HT and MA, are the same, so they have to be parallel as well. And yesterday we talked about what happens when we have parallel lines. We know that in between parallel lines, like these two angles, these are what consecutive angles are. They're angles that are next to each other. So if you want to write it next to, kind of like the word adjacent. But anytime you have consecutive angles, angles that are next to each other, they are supplementary. Now we're going to calculate the length of the four sides. What's nice here is HM, when we calculate that length, because it's a straight line, we could just count the boxes. So 1, 2, 3, 4, 5, 6. And if we did that, we have the same rule that applies for AT or TA. It's also 6 units. Now, because HT and MA are on a diagonal path, we do have to use the distance formula. So remember, we take the square root and we take the points. So since I'm using H and T here, we'll have 0 subtract a -2 squared plus -1 subtract 3 squared. And we'll end up with +2 squared is 4, plus a -4 squared is 16. And we'll end up with a square root of 20. And we're going to do that one more time for our side MA. So for MA, we're going to have the points 4 subtract 6 squared plus 3 subtract a -1 squared two squared is 4 plus double negative here is going to make it +4, 16 again, and we'll end up with the square root of 20, just like we did before. So if you notice, since the lengths are the same for both pairs of opposite sides, that means opposite sides are congruent. So length shows us congruency. Now the last thing we want to look at is the diagonals. So we're going to draw on the diagonals. Remember, we talked about them yesterday. It's HA and MT. Now, if we're looking at that, we want to calculate the midpoint of each diagonal. So we're going to look at MT and calculate the midpoint. Now, the midpoint formula we haven't seen in a while. Remember, we add the x's, divide by 2, and add the y's divided by 2. So we're going to have 4 plus 0 divided by 2. And we're going to have 3 plus negative 1 divided by 2. And we'll get 4 divided by 2 is 2. 2 divided by 2 is 1. So our first midpoint is MT is 2, 1. If we do the same for AH, remember it's always a point because it says midpoint. So AH is 6 plus a negative 2 divided by 2. And negative 1 plus 3 divided by 2. And same thing, we're going to get 4 divided by 2 is 2, as well as 2 divided by 2, which is 1. And they both have the same midpoint. So what do we notice about the midpoints? They are the same. So what do you notice about the relationship of the diagonals? They bisect each other. Remember, if they have the same midpoint, that means they're cutting each other in half. So midpoint goes with that keyword bisect. And that's what we're going to do, is just recap all of those properties on the next side of our sheet here. So parallelograms, they already have all the trapezoid properties, because you'll notice they had at least one pair of parallel sides. They had the same supplementary rule about angles, but they have these diagonals that bisect each other. Okay, so that means these pieces are congruent and these pieces are congruent. They have opposite sides parallel. So remember, parallel is indicated by an arrow. Notice I'm giving 2 arrows here because they're not all 4 parallel. Their opposite sides are parallel. Also, their opposite sides are congruent. So I'm going to give those, actually going to give these. And consecutive angles are supplementary, so any pair of angles that are next to each other. So these two here and here, and then so on around the whole board. Because also one thing we didn't show is that opposite angles are going to be congruent. So opposite angles are always congruent. So if we have that path, we can just set them equal to each other. And now we're going to look at some of those properties in the next couple exercises. Now it tells us we have a parallelogram ABC with diagonals that intersect at L. If it were me, I would always draw yourself a picture with these kind of problems just to get the visual to help. So parallelogram looks something like this. Remember ABCD. It's really important that we go around in a circular pattern. So if I would have wrote C there, it would have been a problem. So ABCD. The diagonals of AC and BD intersect at L. And it doesn't have to be drawn to scale. It does not have to be perfect. But we know that AL is x minus 2. And we also know this whole thing, AC, is 3x subtract 16. What is the length of CL? Well, in this case, we just said the diagonals bisect each other. So that means these two pieces are congruent. That means this is also x minus 2. So what we're going to do here to solve is take x subtract 2 plus x subtract 2 equal to 3x minus 16. And we could have also times that one by 2, whatever works better. Either way, we'll end up with 2x subtract 4 equal to 3x minus 16. And we're going to solve for x. So we'll subtract 2x from both sides, getting x. We'll add 16 to both sides, getting 12. Now, 12 is not your answer, though. Be careful. We want to find the length of CL here. So we got to go back and plug in. So x minus 2 12 subtract 2 is 10. So choice 3. Notice 12 is there as an option to try to trick you. Make sure you're always going back to read that question fully. In parallelogram MNPQ, side MN is 7 inches longer than twice the length of NP. If the perimeter of MNPQ is 68 inches, then determine the length of NP and show how you solved for your answer. Again, I'm going to draw myself a picture here. Now, MN is 7 inches longer than twice the length of NP. NP is our comparison piece. We're comparing it back to NP, which means NP is X. So then, when we read the rest of this here, 7 inches longer than twice the length. So twice is going to be 2x, and longer is going to be plus 7. The other piece that they give us is that the perimeter is equal to 68 inches. And remember, the perimeter is when we add up all the sides. Right now we have 2 of the sides, but one of our properties is that opposite sides are congruent. So that means MQ is also X, while QP is also 2x plus 7. And now that we have all 4 sides, we can use that to find our value of X and to find the length of NP. So 2x plus 7 plus 2x plus 7 plus x is equal to 68. Combining like terms, we end up with 6x plus 14 equal to 68. 6x is equal to, when we subtract 14 from both sides, 54. And when we divide by 6, we get x equal to 9. But we gotta be careful when we plug back in. We're looking for the length of NP. NP was just x, so we write it out as NP equal to 9. Last one here. We have parallelogram ABCD has coordinates given. What must be the coordinates of D, and explain how you found your answer. So let's look what we have so far. We have A is at 7, 1. B is at -2, -3. C is at 0, 3. And we're trying to find out exactly where D lies. Now, we know we need that other piece D. Something we should do is, we know that opposite sides are congruent and parallel. In this case, we could use congruent, but it's going to be harder since we'd have to use the distance formula and try to find an exact point. Here, what I would do is just calculate the slope. So what I mean by that is, let's look at the slope of AB. So from B to A, I'm counting up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 4 over 9. That means if opposite sides are parallel, the same slope would have to be true for CD. So I know that CD has the same slope. So I'm going to count from C now, up 4 over 9. And that's going to be our point. And we could double check that it looks parallel. If we can show that both pairs of opposite sides are parallel, we know it's true. So let's just double check and say CB. The slope there is 1, 2, 3, 4, 5, 6 over 2. which simplifies to 3.